Welcome to Applied Mathematics at Northeastern State University. This is our video number 7. In this video, we're going to talk about chapter 10, geometry, which is actually the first chapter of the last part of this course, part 3. In this part, we talk about geometry and logic, okay? Chapter 10 and chapter 1. Now, some of you guys told me in the feedback about video 0 that your favorite subject is actually geometry. And unfortunately, in this course, we only have this one chapter about geometry, but it's better than nothing. Let's start from a joke, okay, about geometry, okay? What do you call an angle that is adorable? Acute angle, okay? Again, this is something I read online. It's not made by myself. Okay, in this chapter, we only cover section 10.1 and 10.2, which is something really basic. Section 10.3 about fractals is an interesting subject, but it's a little bit advanced, so we decided not to cover that. So there are only 2 sections. Again, this chapter should be pretty straightforward for you guys, okay? So let's start from sharing the whiteboard, okay? So what we want to talk about, okay? Firstly, let's just explain what geometry is. Essentially, this word essentially means earth measure. Geometry comes from all kinds of measurement about the space in the real world, and later on it goes to other subjects, but mostly it's still related to something about space and something about figures in space, right? So that's basically the meaning of geometry. Now there's some very, very fundamental concept that you need to know. Maybe you already know them, but let's just go through them quickly. So the first one is called dimension. Okay. This is a very basic property of a space. Again, let's talk about this by giving examples. Okay, like common geometrical objects like a point. Certainly, as you see, right, if you live in a point, there's nowhere you can go, right? So this is actually 0 dimension. I'll just write a 0D, 0 dimension. Okay. Now, if you can talk about a line like this, a straight line or a curve, right? If you live on a line or a curve, you have a little more space, right? You can go this way or that way, right? But basically, you can only go one direction, right? So they're called one-dimensional object, 1D object. Okay? Now you can also talk about 2D object like a plane, okay? Or a surface in general. The surface could be curved, right? For example, it could be a spherical surface like what we live in on the Earth. In general, it's called surface. Like a spherical surface, for example. Now, these are examples of 2-dimensional objects, right? You know, if you live on those places, you can move either this direction or that direction, right? Basically everywhere on the plane, but you cannot go out of the plane. So it's 2-dimensional objects. And finally, we have 3-dimensional space. There's not actually much of a, let's just call them the 3D space, okay? The space that we live in, okay? Now, there are a lot of 3-dimensional objects. For example, a cylinder or a sphere, right? Now, keep in mind, when we talk about sphere, we were talking about, in this case, when we talk about 3D space, we're talking about the solid sphere, the whole sphere, whole volume in the sphere. Well, in this case, when we talk about 2D, we're only talking about the surface of the sphere. Okay, so these are different. Okay, but anyway, these are the examples we have. Okay. Now, one way to look at dimension and to understand the number of dimensions is use a coordinate system. Okay. For example, if you have certainly if it's a 0 dimension like a point, does not make much sense to talk about coordinate system. But if you have a 1-dimensional system, you can define a coordinate x, and then you can define a point as your origin 0, And then you can define a scale. Let's say this is 0 and 1. And then you can locate any point on the line and give it a coordinate. Okay. Now, certainly because it's on the line, right, you need only one number to specify the point. Okay, whatever point you have. Okay, let's say this one is 3.5. You just need one number to specify the coordinate. Okay. Now, if you have this is a 1D coordinate. Okay. Now, if you want to describe a 2D object, a 2D location, right? You need two axes. Okay, X and Y. Now, for any point, okay, this is your 0. For any point, right, you can locate this point by specifying the two coordinates of that point. Okay. You write the X coordinate and Y coordinate. Sometimes you write like this: 3.5, 1.5. Okay. So these are your two coordinates of this point. Okay. Now, when you have a 3D situation, right, you define other axes. So besides X and Y, you define a Z-axis, okay? Now, because I'm drawing everything on a two-dimensional plane, right? So you have to use your imagination. Imagine that I'm drawing a three-dimensional coordinate system. And this coordinate system actually goes like this, right? If this is your X, this is your Y, and this is your Z, right? The Z direction. X, Y, Z, like this, okay? Now, for any point on the space of 3D, you can specify the three coordinates of that point. Okay. Now let's just say it is 3.5, 1.5, and negative 2.5. Just some numbers. Okay. As you can see here, right, the number in the dimension here is directly related to the number of numbers you need to specify the point. For 1D case, you only need one number. For 2D case, you need two numbers. For 3D case, you want to specify a point, you need three numbers. Okay, that actually, in some sense, defines the position dimension of the space you have. Okay, that makes sense. Okay, now after dimension, okay, the second important fundamental concept we want to talk about is distance. So whenever we talk about geometry, a lot of times you care about distance. Okay. Now a distance is simply if you have taken any 2 points, right? You simply measure the lengths. Now these 2 points could stay in a one-dimensional line, or could stay in a two-dimensional plane, or a three-dimensional space. It doesn't matter. The distance is always defined as the straight line, the length of the straight line between the 2 points. Okay. That's what we call distance. Okay. Now, how do you calculate this distance? Okay. I mean, there's all kinds of ways to talk about it. But one thing you may need to know is in let's say, a two-dimensional coordinate system, you have one point like here. And you want to measure distance from the origin to that point. Let's say you want to get the distance from O to A. And if you know the coordinates of A is given by 3.5 and 1.5. Now, how do you calculate distance from A to O? It turns out that you can use, it is equal to the 3.5 square plus 1.5 square, and then square root, okay? Now, this part is not in the book, so you probably don't need it in doing your homework and quiz, but this is just something you may want to know, okay? Now, this is actually related to a very fundamental result in geometry, which is called Pythagorean theorem. We will talk about that later. Okay. Pythagorean theorem. Okay. Now, as we know, you measure distance, right? In the real world, right? You have a unit, right? You can use either meters, centimeters, kilometers, or miles, or feet or inches to measure it, right? So, okay, the third quantity, I mean, important for the fundamental geometry is called angle. Okay, angle is defined as the given two lines, right? It defines as the kind of like the, I don't know how to say it, but the angle between two lines. Okay, when they talk about angle, it always refers to the angle between two lines. Okay, like this. Now the unit here Okay, the unit here is like meters or foot, okay, depending on which system you use. Now, in the case of angle, one commonly used unit is a degree. And by convention, if you rotate, you start from one point and rotate a whole circle of that point, it is called a 360 degree, right? And you actually don't need any number larger than 360 to define an angle, because after you rotate 360, you come back to the initial position. Okay. Now, you could, based on this, right? It means that if you for the two lines that are like goes like this is actually 120 degree. Sorry, 180 degree. It's like half of the circle. If you go half in circle from this line to that line, it's 180. Now, if the two lines are actually like this, perpendicular to each other, this is actually half of 180, right? So this is actually 90 degree. And you can just divide it and so on and so on. And half of that, right, is basically like say this one right here is 45 degree. Okay. This is just to give you some intuition. Most of you guys probably already familiar with those angles. Okay. Now talking about angle, I remember just another joke. Okay. It's not a joke. It actually happened in real world. Okay. I think there was an NBA star. He went to a team that he changed the team a lot. He took this team from a pretty low level to make it a really good team. And then I don't remember, it's either a reporter or himself talking about this. They say that he completely changed the team by 360 degrees, okay? Which is actually kind of if you really think about it, it seems like a lot of change, but if you look at the definition, right, it's actually make the team go back to the original direction. So I think it's better to say that he probably meant to say that it changed the team like 180 degrees, because then the teams are completely going the opposite direction, from going down to going up, right? So anyway, that's just something interesting. Okay. So I think that's all we need to talk about the really basic fundamentals about geometry, like dimension, distance, and angle. Okay, now the next topic is we want to talk about two-dimensional geometry. Which is actually a important most important subject in this chapter, because 1D geometry certainly is kind of boring, right? When you have one-dimensional case, right, there's only a line. You cannot have anything else. And 3D geometry is a little complicated. Right? It is important because we live in a three-dimensional world, but it's a little complicated. So mostly when you learn geometry in high school, you probably learn about 2D geometry. Okay, so certainly there's a lot we can talk about in 2D geometry, right? Now, in this chapter, regarding to the application to the real world, we just need to know a few things. Okay? Firstly, we need to know all kind of geometrical objects you have in 2D case. Okay? Roughly speaking, there's two kinds of shapes you have. One is a circle, which is defined as a if you draw a line, if you want to draw a curve, that every point on this curve has equal distance to the a point, which is the center of the circle, right? On the plane, then you got a circle. Okay? Now this distance is normally called radius of the circle, right? I'll just call it R here, like R. Now another type of geometrical object in 2D geometry is called a polygon. Okay? The examples be like you have this is like a triangle, which has three sides, or a rectangle, which has four sides, and then they're all perpendicular to each other, or a parallelogram, which also have four sides, but it is actually a little bit, I mean, these two are like, they do not form right angle here, okay? Let me write parallelogram, okay? They're just perpendicular, I mean, they're parallel to each other, but it's not right angle here, okay? And you could actually talk about other polygons like hexagon or pentagon, right? But they're not that fundamental, so we don't normally talk about them. Most time we just stay with these three kind. Okay, certainly a special case rectangle would be a square, but this is actually in some sense it belongs to this category rectangle. Okay, now why don't we need to talk about these more complicated case? Okay, because if you draw lines on inside those polygons, essentially you can divide all these polygons into triangles. So if you understand triangle well, right, you don't need to actually, I mean, you can use the information about properties of triangles to study those polygons, okay? So mostly we just stay with these three kind and then the circle, okay? This is what we need to know. Now what do we need to know about these objects, okay? There's basically, for two-dimensional geometry, there's two kind of important things we need to know. The first one is a perimeter, and then the second one is area. Okay. Okay, let's talk about them one by one. Okay. Firstly, let's talk about perimeter. Okay. For a circle, actually, it's not easy for you to figure it out by yourself. Okay. Now, normally, given the radius of the circle, the perimeter is actually given by a formula like this. Okay, 2 times pi times r, where pi here is just a number, it's a irrational number with infinite number of digits. The leading digit like 3.14 and so on. Okay. Now, why do you have this special number involved in calculating the perimeter, which is the length of this circumference here, right? Why is that? It's an advanced topic. Okay? So for you guys, you just need to know that this is pi times r. Okay. Now, maybe let's talk about the for the circle. Let's talk about the area. Okay, the area formula for the circle is pi r squared. Okay, given the radius, you take the square of it and times pi. Okay. Now we've talked about formulas before, right? And it may look a little bit complicated for some of you guys, but again, remember a formula is just a shortcut. Okay. Algebraic formula is just a shortcut to do arithmetic. Okay. Because you know this, you can plug in any numbers for r. Okay. Now one thing you notice here is when you calculate perimeter, there's only one r involved. When you calculate area, there's a square of r, and that makes sense from the unit point of view, right? Because this is a pure number, this is a pure number. So the unit of this perimeter should be a length, right? It has one arc here. If you start from meter, you get a meter here. So it's consistent. Well, you start meter here for r, the area you got meter square, okay? And that also makes sense because you expect to have a meter square or feet square, inch square, or something for area, right? So it all makes sense from the dimension point of view. Okay, let's talk about the same two properties for triangle and rectangle and parallelogram. Okay. Actually, for perimeter, it's kind of a trivial because you have to know all the three sides of the triangle. Now, in the case of rectangle, because these two are equal, these were equal, you need to know this side and this side. Okay. Now, in the case of parallelogram, you need to know this and this as well. Okay. But after that, you just simply this is just the a plus b plus c, right? Nothing fancy. Now, in this case, you have a plus b, right? A plus b, and then this is another a, so plus a plus b. Because they're equal, so you can write this like 2 times a plus b. Now, this applies both for a rectangle or for a parallelogram. Now, in the special case, when you have a square, a equals to b, right? For a square, you have, if you put a equal to b here, you have basically a plus a, 2 times a plus a. So this will give you 4a. Or you can add them directly like here, a plus a plus a plus a, that's 4a as well. So the perimeter part is pretty straightforward. Okay, now let's talk about area, okay? It turns out these kind of figures for the area, right? The basic idea here is if you start from a rectangle, the area of a rectangle is given by a base times height. It kind of makes sense, right? So you start from here, base, right? And then this goes through again. I mean, imagine you have this line going through the whole, swiping out the whole area, right? It seems like base times height should give you a area, and it makes sense from unit point of view, right? You have one length times another length. This should give you a area, right? Like a meter square. Now, the good thing is, for a parallelogram of the same height and same base, the area is the same. Okay, it's still given by base times height. Okay, now how do you know that? I mean, you can easily see this by drawing some lines here, right, to help you to see, right? See, this part of the area is the same, right? Now this triangle, it's not difficult to see that this triangle equals this triangle. So a parallelogram with same base and same height has the same area as a rectangle. Okay. Now after you understand this, right, a triangle is just very simple, because you can always think about triangle as you cut a maybe not the rectangle, but you can think about any triangle, okay, as cutting a parallelogram in half. Okay, suppose you have a parallelogram, okay, like this. Okay, if you cross the diagonal here, connect the diagonal, you got this triangle. Okay, now certainly because half the parallelogram, so it equals 1/2 times base times height. That gives you the area formula for a triangle. And that's all you need to know about 2D geometry. Oh, one thing I forgot to mention is the definition of base is basically this length. Well, the definition of height is a length that's perpendicular to base, goes to the other side. So this is actually the height. These formulas are all in the book, so you can easily look it up, refer to it in the book. Okay, I'm just trying to explain where it comes from. Okay, now let's talk about the third topic, which is a 3D geometry. As I said, this is actually real geometry that we need to deal with in our everyday life, but it's a little bit more complicated than 2D case. So let's just talk about something really basic about it. Okay, basically we want to know. Let's calculate again consider some geometrical shapes. There are again two type of them. One is called a sphere. This is defined as all points you can have in this space, in the three-dimensional space, that has equal distance to the center, to a point. Okay, that makes a sphere. Okay, another kind is called a polyhedron. Okay, this is a kind of similar analogous to a polygon in 2D case. When you have 3D case, we call it polyhedron. Okay. Now, example of that would be a rectangle box or a square. Sorry, a cube. Okay. Now, certainly you can have a lot of like a pyramid shape or whatever, all kinds of tetrahedron, icosahedron or something, but we don't need that. That's too complicated. Okay? Now, a third kind of object that's kind of interesting is a cylinder. Okay? You could view this as kind of a combination of a circle and a rectangle, because the base shape is like a circle, right? Well, the side, if you cut it, like if you make a cylinder out of a paper, right, like this. Now you cut it on one side, right? It actually is kind of like a rectangle. So it's a combination of circle and polygon, right, to get a cylinder. Okay. Now, what do we need to know about this? Okay. Mostly, okay, for the sphere, we need to know both the formula of area and volume. Okay. So if this radius r, the area is simply given by 4 pi r squared, and then volume is given by 4/3 pi r cubed. Okay. Again, you see this mysterious number pi shows up for both cases, and there's some numerical factors you don't know where it comes from. The only thing you understand is the area should be r squared here, because from the unit point of view, to get a area from a length, you need to square it, right? Now, from the volume point, for the volume, it has to be cubed, because volume needs to be cubed. Okay, but other than that, you don't know where this comes from. Okay, so you just have to kind of remember them. Now, the book also gives the area formulas for polyhedron, like these two, or the cylinder. Okay, now they are not as common as the volume, so I will just talk about volume in this slide video. Okay, now this for the rectangle box is simply given by length times width times height. You can call this length, this is a width, and this is height. Okay, you can actually define whatever length you want as length, and whatever as width, and whatever as height. But anyway, it's a combination of three. Okay, again, it makes sense, because to get a volume, you need to have three lengths multiplied together. Okay, now for a square, because they're all equal, right? So you can say this is like length cube in some sense. If you length to a power cube. Okay. Now, what about cylinder? Okay, for a cylinder, it is actually, if the radius r, the height is h. The cylinder formula is essentially is actually again base times height. Okay? So the base area is pi r squared, and then the height is h. So the volume is pi r squared times height. Okay, actually this formula is the same thing, because length times width give you the base area. Okay, of the rectangle box, and multiplied by height, it give you the volume. Okay, so in both these cases, in some sense, it is still like a base times height. But the base you have is not a line anymore. It's the area, right? It's not a length, it's area. But it's the same, similar kind of reasoning. And that's all we need to talk about on 3D. Okay, lastly, let's talk about a few advanced topics. So firstly, I want to talk about Pythagorean theorem, which is really useful. Okay. Okay, this theorem, the original version is like this. Okay, consider right triangle. Okay, this angle is 90 degrees. Okay, now if you know this side is length A, this is B, and this is C. Now it turns out that there's an interesting relation, simple relation between these three lengths. You have C squared equals to A squared plus B squared. Okay, so given the two lengths A and B, you should be able to figure out C, or given the other two lengths, you should be able to figure out whatever the third one is. Okay. Now this formula can be proved by all kinds of ways. It's actually one of the theorem that has most proofs with it. Okay, we're not going to talk about none of them, right? So, but let me mention one application, just this coordinate system case we talked about before. Let's say you have a point A here, and the coordinate is 4 and 3. Okay, the x coordinate is 4 and y coordinate is 3. Okay, now you want to calculate the distance from this point to the origin. Okay, like this one. How do you do it? Okay, actually, it is a direct application of Pythagorean theorem here. Okay, if you look at this triangle right here, it is like this is 4. Sorry, this is 3, this is 4. I'm not drawing very well, okay? Now you want to know what this length is, right? Now, based on Pythagorean theorem, right, we know that 3 squared plus 4 squared equals this length squared. So to get this length itself, we need to take square root, okay? And this gives us nothing but 5, okay? So using Pythagorean theorem, we can easily figure out the distance of a point to the origin given the two coordinates. And that's just the one out of a million applications of Pythagorean theorem. Okay. Now, the second thing I want to talk about is called scaling law. Okay. Again, this word can mean a lot of different things. In the current context, it means the following. Okay, it means like, let's say you have a length L. Now, if you increase this length, right? If you double this L, let L go 2L. Okay. Now, how will certain geometry quantities change. Okay. Now for a length, right? For any length that's made of L, let's say you have length in one dimension, right? It has a lot of L in it. Certainly, a length would be doubled as well, right? When L is doubled to L, yeah, it becomes 2 times the length. Because every L here doubles, so the whole thing doubles. Now, what about an area? Let's say you have a rectangle box, okay, okay, and then again, this is your unit L here, this unit L here, okay. Because you need to use length times width, right, to get the rectangle, the area, or base times height is the same thing in this case. Because your length is your base and your width is your height. So the area actually is not going to be double because you multiply them together, so it becomes 4 times. Yeah. It becomes 4 times the previous area. Yeah. What about the volume? Yeah. Like a rectangle box. Yeah. In that case, the volume, because given by the multiplication of L times W times length times width times height, right? So each one of them is double, so the whole thing is actually 2 times 2 times 2, so it's 8 times of the original volume. So as the length scale changed, okay, see those different quantities change differently with respect to length. That's called, in the current context, this is what we talk about scaling law. Okay, that's it for this video. And for the bonus question, just tell me some experience you have in your life that you use the geometry maybe to calculate some area or some volume. Maybe you do some housework, building a pool or whatever. Just tell me anything about the application of geometry, okay? And you'll get your bonus point, okay? And thank you for watching, and I'll see you in the next video.